Okay, everybody, make sure that you have your calculator and you have a stylus if you need. Angel, if you need paper copies, you should have already asked. Everybody should have a calculator. Good. You can pause this and make sure that that's the case. If Miss P needs to go get another thing of calculators, please do so. Okay. All right, we're on the third day of word problems. Okay. It's Friday night. I am making a video for you guys. So that's just how I roll. So here we go. William bought 9 tickets to a puppet show, and he spent $52. He bought a combination of child tickets for $4 and adult tickets for $8 each. Write a system of equations, but do not solve. Okay, so remember, just like yesterday when we have these money problems, you're going to have a total equation that's going to have the amount of tickets sold, and then you're also going to have a money equation. So we have to define our variables first. So it looks like you have two different things going on. So do you know what those two different things are, Desmond? You got it, Desmond. Child tickets and adult tickets. So I think a good variable to use would be A for adult and C for child. So he bought 9 tickets total. So one of the equations is going to be A plus B is equal to 9. Adults plus, I don't know why I wrote B. I don't know, I'm tired. A plus C is equal to 9. Okay, so that's the amount equation, how many were bought. Now all the money will go in the other equation. So a child ticket was only $4 and adult tickets were $8. Okay, so those are gonna be the coefficients in front of the variables that will give us $52. So what is this equation gonna be, Mason? No, you were wrong. It's actually 4A plus 8C is equal to 52. So that's our money equation. So since our system is set up like this, Jose, what method are we going to use? Yeah, you got it. We're going to use elimination. So let's try to eliminate the A. So I'm going to multiply both sides by or not both sides, but the top equation by 4. So write this over here. So that's going to be 4A plus 4C is equal to 36. And then the other equation is 4A plus 8C is equal to 52. So what are you going to have to do to these equations to eliminate the A? Let's call on Eric. What are we going to do, Eric? Pay attention, Eric. You're going to subtract 4A minus 4A. So then those are gone. So then 4C minus 8C is negative 4C. And 36 minus 52 is negative 816. So then when you divide by negative 4, you get 4. So now we got to take that and put it back into the amount equation. Always going to put this in the amount equation. Stay away from the money equation. It's always the harder one. So the amount equation is going to come down. And I'm going to have adults plus 4 is 9. So then the adults are equal to 5. So As you could tell, I'm pretty tired because I did just realize it did just say do not solve. But heck, solving's fun. Might as well just do it. Alright. The problems today are not going to involve, at least the first few are not going to involve a system. We can actually solve these without two equations. And I'll show you how to do that. So basically, we got to remember that distance is equal to rate times time. Or in other words, D equals RT. So we're going to have problems here are two objects, so sometimes cars, trucks, trains, they're leaving at the same time, same place, and they're traveling in two different ways, either opposite directions or the same direction. If two, and it's just like systems in terms of opposite and same, that trick I keep giving you about same, subtract, opposite, add, same idea here. So when two objects are traveling in the opposite direction, you're going to use the formula distance equals rate times time plus another rate times time. So to denote the two different rates, we're going to put R sub 1 and R sub 2. So two different rates for two different cars or two different trains, trucks, whatever. If they're going in the same direction, then the distance apart is going to be the first rate minus the second rate, both multiplied by time. Okay. So we're going to be given either the rates and the distance, and we have to solve for time, or we're going to be given the time and the rate, and we have to solve for distance, or we're going to be given the time and the distance, and we got to solve for the rates. So it's just all about what they're asking for. So what are we asking for, and what are the units? If they want to know how long something's going to take, well, that's going to be probably some words, some keywords would be how many hours or minutes, something like that. How far, they're going to be asking for how many miles, how many feet, stuff like that. How fast is you're going to see stuff like, well, how many miles per hour or kilometers per hour, one of the two. Okay, things like that would be your rates. So these are pretty simple. You should find these easy. So two cars start at the same time and they travel in opposite directions. So keyword is opposite directions. So we're going to be using the addition formula. One car is traveling at 25 miles per hour, so this miles per hour right here says that that's going to be a rate. The other car travels at 40 miles per hour, so there's the other rate. So if this we want to call R1, this over here we'll call R2. They're asking here how far apart are they? Well, what is that? Ruba, what is that? How far apart? Is it a distance, a rate, or a time? No, it's not a time, it's a distance. All right, good try. So how far apart? We're looking for a distance, and then we're given after 3 hours right here. What is 3 hours, Isaiah? Yeah, you got it. It's a time. All right, so we're going to use our formula, opposite direction formula, which is distance equals rate times time plus a rate times time. So the distance they're traveling, we don't know. So that's equal to your rate times time, which would be 25 for the first car, traveling for 3 hours, plus 40 miles per hour of the second car that was also traveling for 3 hours. So all we have to do is evaluate that expression. So put that in the calculator. 25 times 3 and 40 times 3, add them up. Brittany, what'd you get? 75 plus 120. Good, Brittany. So 75 plus 120 is equal to 195. Now what are the units we put on the 195? Matt. Good, Matt. It's going to be miles. All right, because they want a distance. Okay, good. So that's all you got to do. There's no system involved. Just setting up one equation and solving. All right, next one. Jim and Sue leave school at the same time on their skateboards going in the same direction. So right away, I see same direction. So I'm going to have a distance equals rate times time minus a rate times time. So write that down right away. RT minus RT. Sue is skating at 4 miles per hour. So right there, miles per hour is a what? Yesha, what's a miles per hour? It's a rate. Good. And Jim is 2 miles per hour, which is another rate. So the question here is how long? So they're looking for the what here. What variable will we not know? Let's call on Diego. Diego, how long? Good, Diego. Yeah, we're looking for a distance. No. We're wrong because they gave us a distance right here, 6 miles apart. So they actually want to know the time. The time is what we don't know. So the 6 miles, which is the unit, that's going to go in for distance, equals my rate, which is 4 for Sue, times time, which we weren't given, minus 2 for Jim times time. Now the order in which I put the 4 and 2 matter because you do not want to get a negative number over here on the right side. So I'm putting the faster person first, Sue over Jim. So we just have to solve this equation. 6 is equal to 2t. Then I divide by t on both sides. So how long will it take? Let's call on... I don't know. How about Emerald? Emerald, how long is it going to take? Good, Emerald. 3. So what are the units attached to the 3? Look at your rate. What would the units attached to time be? We're just talking time. Fantastic. It's going to be hours. So it takes 3 hours for them to be 6 miles apart. All right, Sam and Riley are riding their bikes from school. Good for them. So they left at the same time and are going in opposite directions. So right there is a key word for us, opposite directions. So I know right away, distance is going to be a rate times time plus another rate times a time. Okay, but they're going to be 2 different rates. And it doesn't matter the order in which I do. Sam is going 10 miles per hour. That's a rate. Riley is going 12 miles per hour, which is also a rate. So it then says how long before they're 44 miles apart. So what's this 44 mean, Alex? Is it a distance, a rate, or a time? Good, Alex. That's a distance. So we want to find the what. If it says how long, that's a what? A distance, a rate, or a time. Ravi, distance, rate, or a time? Good, Ravi. You're right. It's a time. So we were looking for that t value. So the distance apart is 44. The rate for Sam is 10. And the rate for Riley is 12. So 10t plus 12t. So 44 is equal to 22t. And when I divide by 22, what do you get, Damien? Excellent job. You get 2. So let's attach units to that. 2 what? Alicia, 2 what? Hours. All right. Good job, Alicia. So 2 hours it'll take them to ride their bike and be 44 miles apart. That's a long time to ride a bike. But Sam and Riley are into physical fitness. So good for them. Good for them. Number 4, Marcus and Lisa are riding their bikes in the same direction from school. Same direction. Right away I see that. I'm writing distance equals rate times time minus a rate times a time. Marcus is riding 3 times as fast as Lisa. Uh-oh. So we have something else here that's going to make this a little tougher. So you got to remember that. If they are 12 miles apart after 2 hours, right here, 12 miles apart, is that a distance, a rate, or a time? Julius, distance, rate, or a time? Good, Julius, that's a distance. All right, and the 2 hours right here, 2 hours. Andrea, that's clearly a time. Good job. All right, so how fast were each of them going? All right, so how fast? That's a rate. We want to find the rate because it says how fast. Okay? So Marcus is riding 3 times as fast as Lisa is riding. So one of their rates is going to be 3 times the other rate. So when I write down all my information from the formula, 12 miles is the distance. The time is going to be 2 for both of them. So it's the rates we have to talk about here. Marcus is riding 3 times as fast as Lisa. So I'm going to put Lisa's rate as R, and then what would Marcus's rate be if he's 3 times faster? Bree, what's Marcus's rate? 3 times faster than Lisa. Good, Bree. 3R is right. So now 12 is going to be 6R minus 2R, which is 4R. So I'm going to divide by 4, and the rate is equal to 3. Now if I look at what R represents whose rate? Who's going 3 miles per hour on their bike? That's so slow. But who's going 3 miles per hour? Is it Marcus or Lisa, Mia? Good, Mia. It is Lisa. So they want to know how fast each of them are riding. So Lisa is 3 miles per hour. And Marcus then, if he's going 3 times faster than Lisa, how fast is Marcus going? He's going 9 miles per hour. Very good. So let's put those units in. 9 miles per hour and 3 miles per hour. Okay. Okay, so key on that problem is understanding that their rates are not the same. So this sentence that I'm circling in red right here tells you that you're going to have 2 different rates, but they're still rates. You're still going to use R as the variable. Okay, some review. Set up the systems and solve. So first thing, we got an age problem. We did some age problems on Friday. So remember, we circled keywords. The sum of ages of 2 brothers, Billy and Mark, is 80. So sum and is going to be key. And then Billy is, that's going to be a key, less than 2 times Mark. All that's going to translate to some algebra. How old is each brother? So 2 brothers, we got Billy and Mark. So we're going to use B and M. All right, so the sum of the ages of two brothers of Billy and Mark is 80. So what is the first equation going to be? The sum of the ages of two brothers is 80. Antonia. Good, Antonia. So we have Billy plus Mark is 80. Next, it says that Billy is, so our B is, which is equals 22 less than 2 times Mark. So we've had this discussion on Friday about this whole less than 2 times somebody else. So is it going to be 2 times M minus 22 or 22 minus 2 times M? Which one is it going to be? What do you think, Jasmine? Yeah, you're right. Good job. You're going to subtract 22 from 2 times Mark. Okay. So what sort of algebraic way can we solve this? Elimination or substitution? What's it set up for? I heard substitution. I agree with that. So let's do one with substitution. I'm going to box the 2m minus 22. And that's going to go in for the B. So then 2m minus 22 plus m is equal to 80. So 3m minus 22 is 80. So I'll add 22. So 3m, what's 80 plus 22? Good job, 102. Then Charlie, when I divide by 3, what do you get? Good, Chuck. You get 34. So Mark is 34 years old. So I'm going to go back into the box. And Billy is 2 times 34 minus 22. Which is 68 minus 22, or 44 years old. No, that's wrong. That's 68 minus 22 is 46. Yeah, there we go. Doing this in my head, people. So you get 46 years old. So Billy is 46, Mark is 34. All right, number 6, we got the perimeter problem. Did some perimeter problems on Friday. Had a good time. So perimeter of a rectangle is 44. The length is 1 inch. That means inches, not in. More, so we know addition is going to be there, and 2 times something is going to be there. Find the dimensions of the rectangle. So what was the formula of perimeter? What was it, Joaquin? Formula for perimeter. Good job. 2L plus 2W. So we know 2L plus 2W is 44. And then it says the length is, so we write always length is, L equals 1 more than twice the width. So we're going to have twice the width, 1 more than that, or we could have 1 plus 2W either way. So what would be the most appropriate method to solve this? I heard a lot of you say substitution. I don't disagree with you. But what I'm going to do here is I'm going to take this bottom equation and I'm going to subtract 2L over. So now it's actually L minus 2W is equal to 1. I'm going to rewrite the original equation below it, the perimeter equation. And this is set up for me to just add these equations together because now I have opposites in front of the W's. So L plus 2W, or L plus 2L is 3L is equal to 45. Or the length is equal to 15 when we divide. So if the length is 15, if you remember my trick that I told you the other day on Thursday, is that the length plus the width is going to be half the perimeter, which is 22. So if the length is 15, 15 plus what is 22? Give you a second to think about that. How big there? Let's call on Angel. How big? 15 plus what is 22? Nope, it's not 9. It's 7. Use a calculator. So W is 7, your L is 15. So this is the dimensions of the rectangle. Alright, 7. The sum of two numbers is 103. So we got another numbers problem. Remember, I told you that you could try to figure these out in your head if you can. But sum, again, is going to be addition. And we got is for equals. One number is 5 less than 3 times the other. So there's going to be some subtraction and some multiplication involved. Find the two numbers. So we define the variables. We said x is the first number and y is the second number. So what's the sum formula? Chris, the sum of two numbers is 103. What is that formula? Good. X plus y is 103. Excellent job, Chris. Then the other equation, let's call on Tommy. One number is 5 less than 3 times the other. So one number we'll call x is 5 less than 3 times the other. So what's that going to look like, Giselle? Good. So 3 times the other minus 5. I feel like doing some substitution. So let's box the x. That's what's going in. So I got 3y minus 5 plus a y is equal to 103. So this is 4y minus 5 is 103. I'm going to add 5 to both sides and get 108. And then I'm going to divide by 4, and I believe that's 27. So I'm going to bring this back into the box, and your x is going to be 3 times 27 minus 5. And 3 times 27 minus 5 is 81 minus 5, which is 76. So my two numbers are 76 and 27. If I add those up, I get 103, which is cool. That's it. Okay. So 29 minutes, that's not bad. So what you have now, you have, what do you guys get, 50? So you got 20 minutes now. Okay, work on worksheet number 11. Okay, just follow the notes. No problem. This is the last day. We have a quiz. This is the last thing you got to know. So we have a quiz tomorrow when I get back. So we'll do a quick warm-up and hopefully do well. All right, you guys have a good rest of your day. Get some homework done. Turn it in. Okay, remember the unit ends on Friday, so the homework competition ends Friday too. So get all your homework in. All right, have a good rest of your day.